Hey everyone, welcome to lesson 8. This is part B, where we're going to talk about logarithmic properties and simplifying log expressions. So make sure that when we're simplifying or condensing and expanding, we can only be using these properties when the logs have the same base. So let's review 3 properties that we're first going to take a look at. The product rule is the log of m times n to the base of b is the same thing as splitting that into 2 separate terms and taking the log of m to the base of b plus the log of n to the base of b. So multiplication allows us to have an addition of 2 terms. Then we have the quotient rule, and the log of m divided by n to the base of b allows us to split into 2 terms, but this time use subtraction between them. So the log of m to the base of b minus the log of n to the base of b. The third one is a power rule. So we have the log of m to the power of k to the base of b is equal to just taking that exponent and pulling out in front as a coefficient. So this is k times the log of m to the base of b. So these log properties allow us to expand and condense or simplify different expressions. So let's take a look at some couple of examples. So this is the log of x times y. We can use the product rule, and we'll separate this log into 2 terms with addition, because that's our multiplication rule. Similarly, for number 2, we have 3 numbers or variables in the bracket, so we separate all 3 of them by addition. So the log of 6 plus the log of a plus the log of b. Next, example 3. This happens to be a quotient example. So this is going to have the terms log of m separated by a negative minus log of n. Number 4, we have something called ln, and it's the natural log, but the properties still apply. So this is the ln of x to the power 4. We pull the 4 out, and it becomes a coefficient of the ln of x. Moving on to example 5, we have something that looks quite complicated, but maybe if we rewrite it a little bit, this is the log of 2 times p cubed times q over r squared. So maybe written like that, we might be able to pull it apart a little easier. So we're expanding this, and we'll use a combination of our product property and our quotient property. So let's start with the log of 2. We're going to go straight across on the top, plus the log of p cubed plus the log of q. And then we have this division by r squared. So that's going to be minus the log of r squared. So we're almost there, other than pulling out the exponents to become coefficients. So we have log of 2 plus 3 times the log of p plus the log of q minus 2 times the log of r. So those are some problems where we practice expanding the logs. Now let's do the opposite, and we'll condense the logs. So the log of a plus the log of b is the same thing as multiplying both. So log of a times b. Over for number 7, we have subtraction, so we know that's the quotient. So log of x divided by divided by y. For number 8, we have a log that has a coefficient here. So when we condense it, we're just going to move that back to be an exponent. So this is the log of p to the exponent of 3. Similarly, for 9, we have a coefficient here of 1/2. So we're going to move that back to the log of z to the power of 1/2 plus the log of w. Didn't do anything with that. But now we have addition, so we're going to use our product property. And so we'll have the log of z to the power of 1/2 times w. Here we're working with the natural log, but it's subtraction. But let me go ahead and do this exponent rule first. So I'll have the ln of m minus the ln of n squared. Now we have subtraction, so we use our quotient rule, and this is the ln of m divided by n squared. Let's move on to simplifying some mixed expressions. And what I want you to remember here is the log of any number to the base of that same number is always 1. So, quick example, let's say I want to find the log of 4 to the base of 4. So the log of a number to the base of the same number always equals 1. So we'll keep that in mind as we go through these examples. So the log of 25 to the base of 2. What we want to do here is we want to rearrange or change 25 into an exponent that has a base of 5. So we will have the log of 5 squared to the base of 2. Then we can bring that squared out, and it will be a coefficient. So we'll have 2 times the log of 5 to the base of 2. Next, number 12, we have subtraction. So we have the log, let's make 8 into the exponent of 2 to the power of 3 to the base of 2 minus the log of 2 squared to the base of 2. So rewriting the 8 and the 4 as exponents with base 2. Then I can pull out the exponents to be coefficients. So the log, 3 times the log of 2 to the base of 2 minus 2 times the log of 2 to the base of 2. And remember, any log of any number to the base of the same number is 1. So both of these simplify to equal 1. And I have 3 minus 2, and that equals 1. So again, the log of any number to the base of the same number is always 1. See how we simplify the others? So we have the log of 81 to the power of 1/2 to the base of 3. Let's see if we can change 81 into an exponent that has a base of 3. So the log of 3, 81 is 3 to the power of 4, but we still have the exponent of 1/2. So let's simplify that exponent rule. So the log of 3 squared, because 4 times 1/2 is 2 to the base of 3. We will bring out this exponent of 2 as a coefficient, so 2 times the log of 3 to the base of 3, and that simplifies to 1. Let's move to the next page. So here we have our quotient rule. We're going to take out our exponent and bring that out as a coefficient. So 7 times the ln of e. Well, this ln is actually the ln of e to the base of e. So this is equal to 1. And so this value becomes 7. And for 15, we're going to bring x out as a coefficient. And they'll have log of 7 to the base of 7. And this log of 7 to the base of 7 is equal to 1. And so it simplifies to x. All right, we're going to expand this example. And we will have, it's again a combination of product and quotient. So let's stay organized here. So this is the log of 3 plus the log of x squared plus the log of y squared minus the log of z. And then we'll just pull out our exponents to be coefficients. So 2 times the log of x plus 2 times the log of y minus the log of 2. We're going to try and condense number 17. So I'm going to start with these ones that have coefficients because I'm going to change them back to exponents. So we'll have the log of a plus the log of b squared minus the log of c to the power of 1/3. And since these are addition, we can use the product rule. So the log of a times b squared divided by the log of c to the power of 1/3. And one last example. So let's see if we can change the 64 to an exponent that has a base of 4. So we will have the log of 4 to the power of 3 to the base of 4. And I will bring out this coefficient, bring out the exponent to be a coefficient. So 3 times the log of 4 to the base of 4. And this is equal to 1. So it simplifies to 3. So why don't you go ahead and give some of the other examples a try in the worksheet, and I'll see you again soon.